activity, you would have had specific tables you had to try to match, okay? So let's kind of try to emulate that process together right now. So let's think about the square root function, okay? So this square root function, we only have values above the x-axis, right? Nothing's below here. All the y values are positive, and we just don't have anything in the negative section. So if I look at my tables, so there's a table here, 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 and there. So I would automatically cross out this one and say this is probably not it, because it has -2, -2 as a point on the graph. But if I look at my graph and go left 2 for -2 and down 2, there's nothing there. So that point doesn't exist on that graph. So it can't be this bottom one. Okay. Then here again and here, both of these have negative x values and then a corresponding positive y value. But we don't have any negative x values at all in this graph. The only table that matches that is this one, because all of the negative x values are listed as undefined. Okay, so we're going to copy that table down into this box. So I'll copy it down. I know you can't see it right now. So negative values cannot go in my square root function. So -2 and -1 will both be undefined. Zero, 1, 2, 3. The square root of 0 is 0. The square root of 1 is 1. The square root of 2 is 1.414, and the square root of 3 is 1.732. What questions do you guys have? Okay. There are no questions. We will move on to the quadratic. Do you guys need a minute to write it down, or are you ready? Okay. So we will go ahead and do our quadratic function. Okay, so we've used this table here. Now our quadratic function should take x values and make them all positive and bigger. So if I look at my tables, I want to check first, just make sure that my negative x values turn into something positive. So here my -1 turns into something positive. My -2 turns into something positive, and so does my -1. And then my last option is down here. But see, my -2 is paired with a -2, -1 to -1. So this can't be an option for a quadratic. So it either has to be this table here, the top one, or the bottom one. Which one do you guys think it is?
The bottom one.
Why do you think it's the bottom one?
Because we're doing x to the second power. And
good. Yeah, and so like if we look here, or maybe even at this 2 squared is 4, but that's not what's here. So it has to be this guy right here. Perfect. So I am going to write that table in for you. We have -2, -1, 0, 1, 2, and 3. Okay, and then the linear function, do you guys still need time to copy it down, or are you ready? Okay, I'm assuming that means you're ready. So we've used this one and we've used this one. So now we're down to these two and we're on the linear function, okay? So when we stick a number in, we should get the same number back out. So which one do you guys think it is? So this one on the left or the one on the right?
Right.
Yeah, why?
Because you get the same output.
Exactly, we get the same output every time. Perfect. So then -2, -2. Okay, and so that leaves the final table for our absolute value. An absolute value takes everything negative and turns it into a positive, but keeps it with the same like quantitative value. So we have -1 and +1, 0, 0, 1, 1, 2, 2, 3, 3. Okay, so those are our notes for the today. So it's talking about function families. We just broke it down into the 4 different function families we're going to focus on. Technically, this is a review from Math 2, but I find it helpful for everybody to just go back through it. Okay, so I'll leave this up here for a second, and then we're going to talk about the next activity you're doing is a Desmos activity, and I'm going to talk you through the first part. And then what I'll do is for the rest of the time, I'll let you guys start working on it and ask me questions as you go, because there are usually quite a few questions on this activity. And I'm asking you guys to do the whole thing today. So I want to make sure that you don't have any questions. All right, can I move this sheet? All right, Tanaya's good. All right, let me know if you need it. I think it's actually already posted, the filled in version. Okay, so here is the other activity we're doing today, and this is talking about shifts and stretches of the quadratic function. So again, this is kind of review. Transformations is something you learned in Math 2, and this activity is basically doing transformations, and we're specifically applying it to quadratic functions, but we could apply this to any of the function families that we just went through. Okay, so let me downsize this and open up Desmos. Make that smaller too. Okay, so you'll open up Desmos, desmos.com, and then you'll click the blue graphing calculator button, and that should get you started. Okay, so the first thing it asks you to do, there are too many things on the screen. The first thing it should ask you to do, it says graph the function y equals x squared. So that's what we're going to do on Desmos. Y equals x. And then to get the square, you can do Shift 6 and then 2. Or if you aren't used to that shortcut, you can just go down and click the little keyboard and then click the square button. Okay, and it'll come up with our quadratic function. Okay, so you want to graph this on this grid right here, but you want to make sure that you are actually graphing it accurately. You don't want to just like throw it down there. You want to actually know what it is. So for a quadratic function, we should always have a point at 0, 0. Okay, and this is just y equals x squared for this particular one. We'll have a point at 1, 1, negative 1, 1, 2, 4, negative 2, 4, let's see, 3, 9, 5, 6, 7, 8, 9, and negative 3, 9. Okay, so this is our y equals x squared function. Okay, if you do not have a printer and can't print out this sheet, that's totally fine. Just make your own little grid out to the side and kind of write out each of these steps as you go, filling in the sentences. Okay. Questions so far?
So I don't have a printer at my house, but I know somebody that does. Do I have to do this now, or can I wait until I get this sheet?
Oh, you can wait until you get the printer if you want. You also just don't have to print it out. If you really want it, you can do that though.
Okay.
Yeah, whichever one you prefer. We're just walking through this so that, because a lot of people get stuck on this activity. So I want to walk through it a little bit and make sure you guys have a good handle on it. So then in step 2, it says using a different color, graph that function. So now I'm going to type that function into Desmos. So y equals, and then we've got a parenthesis and x minus 3 squared plus 2. Okay, so Desmos automatically picks a different color and graphs it for you. I'm going to grab a different colored pen so that I can also graph it. Okay, and so it gives you a few points on here. I find it easiest, well, yeah, you can just graph the points that are given on Desmos. So you can click on them and they'll be there. So the vertex is at 3, 2. So I'm going to go, got right, sorry. I'm going to go right 3 from the origin and up 2 and put a little dot. So let me go back to this. Okay. And then this one doesn't, it just has a horizontal and vertical translation. So it doesn't stretch or shrink the parabola at all. So I know that I could pretend like this is the origin and then just go out from there like I would on the original graph. Let's see. And then the intercept is at 0, 11, which is like up here. So it would go something like this. Okay. And then it asks, or it has some questions there for you, some things to fill in. So the vertex, remember, is this like lowest point, the minimum on the parabola, or it can be the maximum if the parabola is flipped over. And it's at, we went right 3 and up 2. So it's at 3, 2. Okay. And you didn't have to know that off the top of your head. We graphed it on Desmos and it gave us that vertex. And this tells us that to get from the my blue graph to my pink graph, I had to shift right by 3 units and up by 2 units. Okay. Then it wants you to do this again, but with a new function. Now it wants you to do y equals x. Oops, I need these. X plus 4, and then squared minus 5.